To understand the evidence for dark matter, we have to understand how things orbit. And we can understand that by looking at our own solar system. So here's a fictional planet orbiting a star. What you'll notice is that the rules of gravity say that when something is closer in, it orbits faster, and when it's further away, it orbits slower. This can be true of even just a single object if it has an elliptical orbit like this, where it's close to the sun sometimes and far away other times. So you see it speeds up and slows down. And we also see this if we look at just the planets and compare them to one another. So like here's Venus, and we'll see it orbits around at a pretty good clip. But if we were to look at the planet Mars, which is further away from the sun, it orbits quite a bit slower. Right? And if we look even further away, like at Saturn, we'll see that it orbits slower still. Now, this is true of the laws of gravity. So the further away you are from most of the mass, the slower you go, right? And so in our solar system, the vast majority, 99.9% of the mass, is in the sun, right? So as planets are further away from the sun, they orbit more slowly. Now we'd expect to see the same thing in a galaxy. When we look at a galaxy, we see that most of the light is concentrated at the center. And as you get further away from the center, the light gets fainter and fainter. So the light is telling us where the stars are, right? And we know there's like a supermassive black hole in the center. So most of the gravity we would expect is in the center of the galaxy, and there's less and less gravity as you get further and further away. And so what you would expect to see is that things orbit more slowly as you get farther from the center of the galaxy. Well, this is something that we can measure both within our galaxy and when we look at other galaxies. So here's what we'd expect to see. We'd expect to see here on the left-hand side is that things orbit really fast in the center, around kind of like Mercury going close to the sun. And as you get far out in the galaxy, things orbit much more slowly. And you see it represented in this graph at the bottom, where the velocity is the most towards the center, and it tapers off as you get further away. In reality, though, that's not what we observe. We observe that the whole galaxy appears to be rotating at a roughly constant speed, so that even the parts of the galaxy that are far from the center are orbiting just as fast as the parts that are near the center. Let's look at that again. Right, so we see here these guys on the outside are moving pretty fast, just like the stuff on the inside. And that's represented by this graph here showing the velocity is roughly a constant throughout that whole galaxy, even as you get further away. Here's some other data, another way to show it, right? These are called rotation curves. And you can see that for many different galaxies, including our Milky Way, which is marked in red, the velocity, the rotational speed, is roughly a constant as you move away. Now, the only way to understand that, based on our best understanding of gravity, is that there must be more material, more matter distributed throughout the entire galaxy. Matter that we can't see. It's not shining like stars are shining. And it's not shining in any other wavelengths of light either. So that's where we get this idea of dark matter. We see that there must be matter there because the gravity is telling us it must be there to cause this kind of rotation, but we don't see the light from it. So that's what we call dark matter.